Hello children, today we will start from page number 146, properties of and uses of metals. Heading is properties of aluminium. So first the physical properties of aluminium: nature, silvery light metal, malleable and ductile. So these are the typical metallic properties of aluminium. Conductivity, good conductor of heat and electricity. Boiling and melting point is given here. Boiling point is 2050 degrees Celsius and the melting point is 660 degrees Celsius. Now chemical properties of aluminium. In air, unaffected by dry air but tarnished in moist air. Tarnished means metallic lusters is removed. Forms a thin film of Al2O3 which prevents further oxidation. So aluminium sheet form a thin film of Al2O3. Due to it becomes tarnished in air, in moist air. On heating, in air burns with a bright light, forming aluminium oxide and aluminium nitride. So formation of aluminium oxide due to the presence of oxygen in air, and aluminium nitride due to the presence of nitrogen in air. So these are the reactions for the formation of aluminium oxide and aluminium nitride. So these two gases are present in air, aluminium reacting with air and forming a related compound. So aluminium when reacts with oxygen forming aluminium oxide, and aluminium when reacts with nitrogen of the air forming aluminium nitride. Next, water. So unaffected in pure water but liberates hydrogen when steam is passed over red hot aluminium. So this is the reaction: aluminium with water, steam, forming aluminium oxide and hydrogen. With non-metals, it is showing direct reaction with halogens. For example, with chlorine, it is forming aluminium trichloride. Aluminium chloride, aluminium trichloride when heated with chlorine. Then with sulfur, so in the presence of sulfur, it forms aluminium sulfide when heated with sulfur, Al2S3, and the reaction is exothermic in nature. Okay students, so chlorine and sulfur, these two are non-metals which are reacting with aluminium in different conditions and forming related compounds, chloride and sulfide. Then reaction with alkalis, so forms aluminates and liberate hydrogen. Aluminium with sodium hydroxide and water, it is forming sodium aluminate and hydrogen. With potassium hydroxide and water forming potassium aluminate and hydrogen. So salt plus hydrogen is formed. Then reaction with acids, with hydrochloric acid forming aluminium trichloride plus hydrogen, with sulfuric acid forming related sulfate with hydrogen. So aluminium is reacting with dilute and concentrated sulfuric acid. Okay, the difference is there that with concentrated sulfuric acid, SO2 gas is released. SO2 gas with suffocating odor. Then reaction with nitric acid, with dilute or concentrated nitric acid, aluminium is rendered passive due to the formation of thin layer of aluminium oxide. So dilute and concentrated nitric acid both oxidized aluminium in the form of aluminium oxide, and that is why further reaction of the aluminium is not possible with nitric acid. Okay, then reducing agent. Aluminium itself is a very good reducing agent, and it reduces heated metallic oxide of iron, chromium, manganese in the form of metals. So again the reaction is exothermic in nature. So aluminium, a metal, is also acting as a reducing agent and reduces number of metallic oxide in the form of metal. For example, ferric oxide when reacted with aluminium forming aluminium oxide and iron. Then uses of aluminium. So household use form of aluminium is aluminium metal. Application: molded into utensils. Reason for use: aluminium metal is light, cheap, corrosion resistance, good conductor of heat, unaffected by food acids. Okay, so these are the reasons why we are using aluminium utensils in home. So metal, light metal, cheap, corrosion resistant, good conductor, and unaffected by food acids. Then we are using form of aluminium powder plus linseed oil in the form of paints. So application of this type of paint is it is applied generally on iron poles. Reason: aluminium layer prevents corrosion of iron. Anti-corrosive paints. So aluminium paint is used as anti-corrosive paints and it resists iron pole from corrosion. Then packaging. So in packaging, thin aluminium foils are used. Application: foil used in food packaging and packaging of articles like photographic films. Reason for use: aluminium metal is corrosion resistant, has a bright appearance, and is very light and cheap. So these are the reason why we are using aluminium sheets for packaging purposes. Then electrical cables, and here we are using aluminium wires. Cables and transmission wires. What is the reason for this use? Aluminium is a good conductor of electricity. Then aluminium alloys. Duralumin, which is the mixture of aluminium, magnesium, copper and manganese, and magnesium, aluminium and magnesium. So these alloys are used in aeroplanes and in the formation of light tools. Reasons: aluminium alloys is light, has high structural strength and corrosion resistance. So these three are the reasons, 3 points of the reasons why we are using aluminium alloys in aeroplanes and for making light tools. Then thermite welding. This is the very important use of aluminium, thermite welding. In thermite welding, and here we are using thermite mixture, which is the mixture of ferric oxide and aluminium. So in this mixture, reduction of metallic oxide with aluminium is known as aluminothermy or thermite process. So actually what happened here, aluminium reduces ferric oxide in the form of iron. Okay students, so we are using here ferric oxide and mixture of aluminium as a thermite mixture. Application: this mixture is used for welding for the broken ends of an iron girder. Reason for use: aluminium powder is a strong reducing agent and reduces Fe2O3 to iron. This is the reaction here. Reduced molten iron sinks and flows into the gap of the girder, thereby welding it. So as you can see here in the diagram of thermite welding, this welding is known as Goldschmidt thermite welding process. Okay students, so this is the main portion of this apparatus. where we filled a mixture of iron oxide and aluminium, and this mixture is filled here in this part of the apparatus, which is having an opening at the bottom side, and this opening is set according to the broken part of the iron girdle. Okay students, and after that we ignite a magnesium ribbon which is present here. So before this ignition, this aluminium is reduces Fe2O3 in the form of iron, and same time this ignite magnesium created so much amount of temperature here. In presence of that temperature, the iron get converted in the form of molten iron, and this molten iron is come out from this opening and sinks here in between the broken end of the iron girdle. So these end will be joined together. Okay students, so this is the process which is taking place here. So magnesium ribbon is creating that much temperature which is helping to convert iron which is formed after the reduction of ferric oxide in the form of molten iron. Okay, you can see that these are the alloy of aluminium and duralumin and magnesium. So duralumin is having aluminium 95%, magnesium 0.5%, manganese 0.5%, and copper 4%. Magnesium, aluminium 95% and magnesium 5%. Okay students, so property and reason for alloying. First is duralumin. Aluminium imparts lightness and magnesium imparts strength. So in duralumin we are using aluminium, magnesium, manganese and copper. So what is the reason for the use of aluminium and magnesium in duralumin? So reason for the use of aluminium is it imparts lightness and magnesium imparts strength. Now duralumin is used for the aircrafts to prepare the body of aircrafts and light tools, and also in the formation of cooker. Then magnesium is light, hard, tough, corrosion resistant. Okay students, so this is the property of alloy. So this magnesium is used for the aircrafts and scientific tools. So from here you can find out what percentage of which metal is used in the alloy of aluminium, and second thing, what is the purpose of the use of that particular metal in the alloy. Okay students, then so overall this much from this chapter. Rest all the things related to zinc and other metals is not in according to your reduced syllabus this session. So this much you have to prepare only related to aluminium. Okay students, thank you very much.